Welcome back to another exciting chemistry lessons.
Baby, you were born to win. Never give up, never give in. You were born to win.
In the previous lesson, we learned about Lewis dot structure. We also learned how to draw a Lewis dot structure with single bond, double bond, and triple bond to show how electrons are shared between atoms to have that octet valence electron. Or for hydrogen, it would have 2 valence electrons. Now we are going to look at the composition of single bond, double bond, and triple bond. Well, these 3 types of bond are made of sigma or pi bond, or a combination of both sigma and pi bond. In this case, a single bond is made of 1 sigma bond, a double bond is made of 1 sigma and 1 pi bond, and of course, a triple bond is made of 1 sigma and 2 pi bond. First, let's look at sigma bond. Sigma bond is formed from a head-on overlap of different type of orbitals. In this case, we have S and S and P, or P and P. If you look at the structure right here, the key thing about sigma bond is that you look at the structure the way it is overlap, you can see that there are possible free rotation. So that's the reason why when you have a single bond, the atom actually rotate around the single bond. And that's the beauty behind single bond. The atoms are rotating around it. So now let's look at pi bond. If you look at pi bond, the pi bond are formed from side to side overlap of 2p orbitals, okay? So these are 2p orbitals. And if you notice, there are 2 locations of electron interaction. And because you lock them up together, it is almost impossible to rotate. So therefore, you do not have that free rotation like a single bond. So now let's go back up here and look at the type of bond more carefully, and we can learn about their characteristics based on the composition of sigma and pi bond. Well, we learned that single bond again is made of sigma bond, and because it's made of 1 sigma bond, it is allow free rotation. And look at the bond order, it's related to the type of bond. Single is 1, double is 2, triple is 3. And later on, you are going to use the bond order later. Now, in terms of length, well, length is really related to bond energy. The stronger it is, the shorter the length. That means the closer they are, the stronger the attraction, therefore the greater bond energy. So you have to think of that, okay? So in this case, we have a short triple bond. That means the strength here will be greatest, right? It will has a lot of energy. So in order to break the triple bond, you would need a lot of energy. Where in terms of the single bond, you would have a longer length, and therefore release the least amount of energy. That's why some atoms are so easily losing the single bond and completely give up that particular atoms. Well, of course, for double bond, you would have in between, and they would have an intermediate level of length and energy. Now let's do an example problem. Describe each bond in the Lewis dot structure above. So in this case, we have A, B, C, okay? So bond A is what? Well, bond A is right here. It is a triple bond, okay? That is made of what? 1 sigma bond, and you can learn that from the table. Or just use your common sense, okay? Single is 1 sigma, double is 1 sigma and pi, and triple is, of course, 1 sigma and 2 pi. In this case, 2 pi bond. It has a bond order of, what does the prefix tri represent? Well, that is 3. And then it would have what? The shortest bond length. And of course, with the shortest bond length, you would have the greatest bond energy. Now let's go down and try another problem. In this case, we have B. Well, what is B? Well, bond B right here is a what? It's a single bond. It's made of 1 sigma bond, and we know that it doesn't have any pi bond at all. And of course, it has a bond order 1, okay? Just the word single right there. And it has what? The longest bond length. Therefore, the least bond energy. And here's the key thing that you have to realize. This right here is allow free rotation, okay? So every time you see a single bond, it's allow free rotation, where triple bond and double bond would not have a free rotation. And now let's go to the website and check our answer. Here we have the bond A, and we fill in, and let's check it. And there you go. So that is how you look at Lewis dot structure and determine the composition of single bond, double bond, and triple bond. But most importantly, we can now learn about the length, the energy, the bond order, as well as the rotation at that particular bond. And as always, if you have any questions, take a picture of your work, put in the forum, and we will help you from there. And we see you next time on another exciting chemistry lesson.